Hi, so today we're going to talk about the pet clinic application. There's not much else to say about it aside from the fact that we've deployed it. So if you want to note down the IP address there to access the site, you can. With that being said, let's get into Jenkins and kind of what we did with it. So as you can see here, we installed a static analysis tool, which we were able to see kind of the ongoings of the project as we went. We also installed the plugin Jacoco, which allowed us to see test coverage throughout the system. So we used this throughout the project for local development, and we would be able to get the logs of our various builds and see whether they passed or failed. So as you see, it's quite simple. Most of it are just the various packages kind of depending on one another. They're quite tightly coupled because it's a basic CRUD app, so each one of these is based on the model, and each of them is editing kind of different files within that model. This is the initial commit. There's quite a bit of tests in the various files, and each one of them has several different tests that are run. And roughly 91.5% of the code is covered. There's no flaky tests after 25 different runs. And in terms of technologies used for testing, we mostly saw at the beginning that it used mock MVC to perform API calls. We noticed that getters and setters are never tested in this application. In terms of tests for the old system, we've added things like, for example, pet validator. Before, there wasn't pet validation being done, and so that part of the code wasn't being covered as much. So this file kind of just goes through and verifies that the various pets that are created should or should not validate. So for example, we have a pets here that should validate here. Coco should validate, whereas here there's no name, so it's going to fail to validate, so it should fail to validate because of name. Here we don't have a type, so it's going to fail to validate because of type. I'm just going to go through how the migrations dashboard works. So first we start by clearing the current version of whatever's in the SQLite database. Then we go and forklift over the data. Before we do that, we can just show what's in the database. So right now there's no data in the database. We come here, we forklift the new data. A bunch of data is added in from the old service, from the old database service. We refresh here, you will see that all of the owners, pets, and all that stuff is in the system. Then we are able to, before we run the consistency checker, let's add a new owner. Just going to go through the motions. Add visit. Now we can go back to the migrations dashboard and we can run our consistency checker. And you'll see that we've added a new visit, we've added a new pet, and we've added a new owner. So it was a total of 3 inconsistencies, and it was able to find them and as well as add them to the new data store. So if you'll see here, we can re-execute the query. We have 13 now, Jonathan 2, and if we go to pets, the new Coco is added. Okay, so we're going to talk a bit about data migration and kind of how everything works, as well as the diffs to kind of show our process. So let's start with the forklift diffs. So we have some statements for if we want to drop the tables, if we're doing it as an exercise to kind of show that when we start up the app, it automatically drops everything. We also have an initializing schema, which creates the database back from scratch so that it's an empty database, but with the correct structure. It has an instance of both the table data gateway as well as the SQL DB. These are both the connections to kind of a layer that's over top of the database as well as the actual database itself. So when we init the schema, it drops all the tables. Right now in future commits, we actually have a feature toggle that toggles whether or not we do this. So for example, here we're able to lift all the vets in the system. So we use the interface vet repository, which is their ORM for their old data store. And we're able to find all of them as well as, and then iterate over them, inserting each one into our own database. And the table data gateway handles the work from there in terms of actually inserting it into the database. So here we're looking at the consistency checker, and we want that when changes to the old system happen, that the consistency checker, when it's executed, is able to take those changes and update it into the new system. Basically what we have is for each table we have a checker, and that checker iterates through the old, comparing it to see if it's in the new. And we're able to, if it's not there, add it to it, as well as increment the changes of each one, both the inserts and the updates, to our consistency score. We have a consistency score that is accessible from everywhere in the system, so that when we want to display the score, we're able to display it. Okay, so here we can see that in the shadow reads file, whenever we are trying to read from the old data store, we're also reading from the new data store and making sure that if it's not correct, that we're correcting it. So here we're talking about shadow writes, and we want that whenever we write to the old system, we're also writing to the new system. The old system is saving the owners into the database whenever it's adding a new owner. But what we want to do is also be able to write to our data store whenever this is happening. So we're going to talk a bit about A/B testing. And so the definition of A/B testing is randomized experiments, A and B. Users have a chance of getting either feature A or feature B. Their interactions are logged in a structured format, in our case it's JSON, so that the effectiveness of both features can be measured. One example hypothesis that we had was being able to create an owner and his pet is 1.5 times faster if we use feature B over feature A. I'll show you feature B and feature A. So feature A is the one that is originally in the system. So for example, adding an owner and his corresponding pet. We add the pet, add it. So what we're able to do is, if we turn our feature on, do redirect pet after owner creation. Set that to true. We can find the owner, add the owner. Directly, we're at the new pet page as opposed to going to the owners page, and we're able to add a new pet. And so our hypothesis would be that it's 1.5 times faster to do this. So this is an early version of the toggle manager. It has less toggles than it does here, but you'll see that the names of the toggles on the website are exactly as they are in the file. And so when we change these, the site will actually auto update with what their variable names are called. And this is done using Java reflection. And so essentially we're able to get a list of a list of all fields in this particular class, check if the field is static, then add them to an array of toggles, and that's what the toggle object was for earlier, and we're able to basically return that to whoever needs it. In the case of the logger uses this method in order to serialize all the toggles so that they can be effectively displayed when we're logging. Logger stores logs in a logging database. Here's an example of our logging database. So each log contains the log name right here, whether it's an A or a B feature right here, as well as the current state of the toggles at that moment. So here we can see that we have a JSON object of the current state. So each one of these is a key with its corresponding value. So for example, we can see here that when this log was invoked, it's a do redirect to new pet page after owner creation, false. So the feature is, this particular feature is off. So we can know exactly for each log the exact configuration of the system at that particular moment. So let's just take a quick look at the diff here, because that's what we're interested in terms of code. So it's pretty simple. What it does is it essentially adds the keys to the JSON object that we just talked about. It adds the current state of the feature toggles to the JSON object. It prints it. The current version of it doesn't do that because it was way too long. And then we save it into an SQLite database. Next, we're going to talk a bit about the rollback and how we accomplish this, and just show that it's possible to do a rollback. Yeah. So if we look here, we see that we have two experiments. We have experiment A and experiment B. And each of these experiments expect different results. So we expect to be redirected to pets directly here, and we expected to be redirected to the owner page here. And so this is our demonstrating the rollback. So we're able to, we reset the logger, then we use feature A, and we execute the experiment of feature A, turning on the correct toggle. Then we use feature B, execute the experiment B, make sure that the feature is on when we turn it off. When we turn feature B on, then we turn feature B off, and then we use experiment A again. And so we're able to see that both we can use feature A, then use feature B, then roll back to feature A. We have many features, and so this is another example of one of them. Here we're just showing that we're able to collect a lot of fake data using the math.random method. So we say, like, if it's less than 0.5, then use feature A, else use feature B, and we're able to collect a lot of data, too much data. So I just want to thank you for listening to this boring presentation. Our app is deployed at this particular URL, as well as the log database and migration database, which are both accessible at ports 8081 and 8080 respectively.